Hello to all. This is Dr. IJR initiating online lecture series on operations research. Today we are going to learn about Hungarian method of assignment problem. In this lecture, we are going to learn about degeneracy case of assignment. So what is a degeneracy? Means number of rows is equal to number of columns is not equal to number of assignments. So this is referred as a degeneracy case. If number of rows is equal to number of columns is equal to number of assignments, that is referred as non-degeneracy case. Please see my previous video on non-degeneracy case. Let us start with one problem. Here, there are 5 workers are given and 5 jobs are given. That means it is a balanced problem. See, number of rows is equal to number of columns. So we have to check that whether it is a balanced problem or not. For any assignment problem, it is mandatory to check whether it is a balanced problem or unbalanced problem. So in this case, there are 5 workers are given and 5 jobs are given. So that means it is a balanced problem. So once we confirm that it is a balanced problem, so we have to apply the step 1 row minimum. Identify the least element of each row and lessen that element from all the elements. So that means the first one is 3, 16, 43, 23 and 13. So lessen this number like this, 13 minus 3. 33 minus 16, 16 minus 16, 29 minus 16, 36 minus 16, 39 minus 16, 43 minus 43, 56 minus 43, 65 minus 43, 72 minus 43, 89 minus 43, 23 minus 23, 36 minus 23, 45 minus 23, 82 minus 23, 24 minus 23, 13 minus 13, 46 minus 13, 54 minus 13, 66 minus 13, 75 minus 13. So once we do the calculation, so we can get the table like this. This is the table 2. So again check that. So see in the note, if all the columns are already having at least 1 0 after step 1, then ignore step 2. Directly we can do the assignment. But in this case, see the job 1 column, job 1, yes, zeros are there, job 2 zeros are there, but job 3 there are no zeros. Job 4 there are no zeros, and job 5 there are no zeros. So that means we must do step 2 also. What is step 2? Column minimum. Identify the least element of each column and lessen that element from all the elements of the columns. The first one is 0, second row least is 0, third row least is 6, 8 and 1, and lessen these numbers like this: minus 0, minus 0 and minus 0. Second row minus 0, minus 0, minus 0, minus 0 and minus 0. This is 6 minus 6, 13 minus 6, 22 minus 6, minus 6, minus 6, minus 8, minus 8, minus 8, minus 8, minus 8, minus 1, minus 1, minus 1, minus 1 and minus 1. So once we do the calculation, the table is like this. This is the table 3. So check that all rows and columns are having zeros. Yes, all rows are having zeros and all columns are having zeros. So then we can do the assignment. How to assign row process? First we may give preference to the row which are having only 1 0. If more than 1 0 is there, so we can leave that row for time being. You see the first one W1, there are 3 zeros are there. So leave that particular row, and the second one there is only 1 0 is there. You can directly assign this one and check that whether is there any zeros in that column or not. There are no zeros on it. Otherwise you can strike off that zero. Third one, there is only 1 0 is there. Yes, there are 3 more zeros are there. You can strike off the zeros like this. And W4, actually there are 2 zeros are there, but recently we strike off with 0. So for time being we can assume that there are 2 zeros are there. So the row process completed. And now we can move to the column process. So if the column contains only 0, then assign immediately, otherwise leave that column and focus on other. So job 1 already assigned, job 2 already assigned, job 3 there is only 1 0, yes, only 1 0 is there, we can directly assign. But in that row W1 there is 1 0 is there, so we can strike off that 0. Why? Because W1 is already assigned to job 3. That means W1 is not available to job 4. That's the reason we can strike off that. And job 4, no zeros, job 5, yes, only 1 0 is there. So after completion of this, check that if there any leftover zeros are there. So there are no leftover zeros. So that means we can complete the assignment and check that whether this is a non-degeneracy or degeneracy. That means number of rows is equal to number of columns is equal to number of assignments. See, number of rows is equal to 5, number of columns 5, but number of assignments are only 4. That means it is not equal to. So we can say that it is a degeneracy problem. So if we get this type of problem, what is the procedure to solve this problem? So in this case, so you have to follow these particular steps. To solve this problem, we have to do the following steps. First, identify the unassigned row with a tick mark. So first, this is very much important, unassigned row. Next, find out zeros in that row and put tick mark at column. Out of that marked columns, find out assigned cells having zeros and put tick mark at rows. After completion of the process, then cover unmarked rows with solid line, cover marked columns with solid line. So let us apply these rules to the table. This is table 4 and this is the assignment. And see and check that what is unassigned row. W1 is already assigned, W2 already assigned, W3 already assigned, W4 already assigned, but W5 not assigned. So that's the reason we can put tick mark here like this. This is unassigned row. And see that is there any zero in that? Yes, 0 is there. We can put tick mark here. And this 0 is situated at job 1. So on the job 1 column, is there any assignment is there? Yes, there is one assignment. This assignment is at W3. So we can put tick mark here W3. And once you put the tick mark, again check for 0 other than assignment. See there are 13, 16, 21 and 45. That means no zeros are there. So that means the tick mark process is completed. Once we put the tick mark, what we can do is cover unmarked rows and cover marked columns. So what are the unmarked rows? W1 is unmarked. So that's the reason we can strike off this particular row like this. And W2 is also unmarked. We can strike off the line like this. And W4 we can strike off like this. Unmarked rows. And here is marked columns. Cover marked columns. So how many marked columns are there? Only one. So that is job 1. So we can mark this one. So finally we have 8 open elements are there. 13, 16, 21, 45, 33, 35, 45, 61. So 8 open elements are there. So once we do complete this process, what we can do? So you can see the rules like this. After completion of marked columns and unmarked rows with solid lines, then we have to do one process. That is the golden rules is there. You need to memorize this one. Identify the lowest number from the open values or open elements. Second one, subtract that number from open values. Add that number at intersection. And one more important rule is no change in cover value. So after completion of all the rules, we have to check that all rows and columns are having zeros or not. If yes, proceed for assignment. If not, apply row minima or column minima. So this is the process. Out of it, there are open elements are there. So out of this minimum value. What is the minimum value of open elements? Minimum value of open elements is 13, 16, 21, 45, 33, 35, 45, 16. So that is 13. So we have to subtract this minimum value from open elements, that is 13 minus 13, 16 minus 13, 21 minus 13, 45 minus 13, 33 minus 13, 35 minus 13, 45 minus 13, 61 minus 13. For the completion of subtraction, so addition, add minimum value at intersection point. See what is intersection? Here, this is the intersection point, so we have to add this minimum value, that is plus 13. This is one more intersection, plus 13. Here also one more intersection, that is So after addition, lessening, so we can get a new table. This is table 5 like this, 13,300,009. So like this. So once we get this new table, check that all rows and columns are having zeros or not. See this, all rows and columns are having zeros? Yes. So all rows are having zeros and all columns are having zeros. Now assign. Or having at least one zero. That means we can assign. So what is the thing? Row and column process. First row process only one zero. First we need to consider only one zero. W1 there are two zeros. Leave it. W2 only one zero is there. You can directly assign and strike off the remaining zero here. W3 actually there are two zeros are there, but recently we strike off one zero. So for time being we can assume that there are two zeros. Leave that one. W4 yes one zero is there. We can directly assign. W5 only one zero we can directly assign, and there is one more zero is there, we can strike off that zero. So here the row process is completed, and now column process, job 1 already assigned, job 2 already assigned, job 3. There's only one zero is there, we can directly assign, and there is one zero. W1 is already assigned to job 3, that means W1 is not available to job 4. That's the reason we can strike off that particular. So after completion of this, if there any leftover zeros are there, you can check. So there are no leftover zeros. So that means we can check that number of rows is equal to columns is equal to assignments or not. So that is 5 equal to 5 equal to 4. That means again it is a degeneracy problem. So degeneracy means unmarked cover unmarked rows cover unmarked cover marked columns. So check that is there any unassigned row is there. W1 already assigned, W2 already assigned, W3 not assigned. So that's the reason we can put tick mark like this. W4 already assigned, W5 already assigned. So we have to consider on W3. So we have to put tick mark like this and see is there any zeros in that. Yes, there are two zeros are there. That zero is in job 1 and job 2. So that's the reason we can put tick mark like this. So once we put the tick mark, the first tick mark is in job 1. Is there any assigned value is there or not? We have to check. Yes, there is one assigned value at W5. We can put tick mark like this. And see the second tick mark on the job 2. There is one assignment is there at W2. We can put tick mark like this. And check that is there any zeros are there in the tick mark 7, 12, 22, 30 other than assignment, no zeros. And the last one 20, 22, 32, 48 other than assignment, no zeros. So here the process is completed. So we can set that cover unmarked row and cover marked column. So what are the unmarked rows? First row, so we can strike off this one like this, and W4 also strike off. And cover marked columns. There are two marked columns are there. We have to cover like this. We have to cover like this. So now we have 9 open values are there, 7, 12, 22, 3, 8, 32, 22, 32, 48. So we need to identify minimum value. So what is the minimum value of open value? 3. So subtract minimum from open values. So that means 7 minus 3, 12 minus 3, 22 minus 3, 3 minus 3, 8 minus 3, 32 minus 3, 22 minus 3, 32 minus 3, 48 minus 3. After completion of this, we have to add this minimum at intersection points. So what are the intersection points here? Yes, 13 plus 3, here also 3 plus 3 and plus 3. So after completion of this process, add and subtract, so we can get this new table like this. Yes, this is the new table 16600 like this. So once we get this new table, again we have to check all rows or columns or having at least one zero or not. See this, the first one, yes, 0 is there, double is 2 0. So all those are having zeros and all columns are having zeros or not. So all columns are having zeros. That means now we can proceed for assignment. So what is the first one? Row process. Row process. So only constant on single zero. W1, there are two zeros are there, leave that row. W2, there's only one zero, we can directly assign like this. And see, there is one zero in that particular column, we can strike off that two. W3, there are two zeros are there, so leave that one. W4, yes, one zero is there, we can directly assign. W5, one zero, we can directly assign, but there is one more zero in the job one, so we can directly strike off. So row process is completed. Now we can do the column process. So complete on a single zero. So job 1 already assigned, job 2 already assigned, job 3. Yes, there are two zeros are there leaded. Job 4 is only one zero. We can directly assign like this and strike off this one. And there is only one zero left over, so we can directly assign like this. So this one is completed. And now check that number of rows is equal to number of columns is equal to number of assignments. So 5 equal to 5 equal to how many assignments? 5. Yes, this is non-degeneracy problem. So we successfully converted a degeneracy problem to the non-degeneracy. So that means the problem completed. Now we reach to the optimal solution. So we can directly take the original table like this. So these are all the yellow color is the assignment one. So we can prepare this particular table. That means W1, W2, W3, W4, W5, and machine. What is the first machine? W1, job 4. What is how much? It is 11. It is 11. And W2, it is job 2, it is 16. W3 is job 3, 65. W4 job 5 is 24. So 24. W5 job 1 is 13. So sorry for not I didn't delete this color. Sorry for that. But don't worry about this. So just add the numbers and we can get 129. So that means we reach to the optimal solution. So this is the combination, best combination W1, J4, W2, J2, W3, J3, W4, J5, and W5, J1. So total is equal to 129 hours or minutes. So whatever the given measure or parameter in the problem we have to write. So this is the optimal solution. So 129 is the optimal solution. So this is the way to convert a degeneracy problem into the non-degeneracy problem. So I hope all of you understand this degeneracy case. So thank you for watching.